Okay, we've got this nice physics problem here. We've got some position function. I want to know, when is the particle at rest? That means this question is, when is the velocity equal to 0? And velocity, remember, is the derivative of position. So I have to take the derivative here. S prime of t, also known as the velocity function. 2 times sine, the 2 just comes along for the ride. Derivative of, this is an equals here. The derivative of sine is cosine. Write that a little prettier. I don't think that was any prettier. Minus derivative of t. The derivative of t is just 1. I want that equal to 0. So I want twice cosine of t minus 1 equals 0. So that's 2 cosine of t equals 1, or cosine of t equals 1/2. Now, if you know unit circle and you've got that memorized, you can just bust these out. I prefer to use reference triangles. But like, you might have this question on a test. You ain't got time to redraw all of unit circle to figure this out. Here's my recommendation for figuring this out. First, all students take calculus. So where is cosine positive? That's quadrants 1 and 4. Cosine's positive here. When does cosine equal 1/2? The way my mind works, here's how I would think about it. I know sine of 30 degrees, pi over 6 is 1/2, because I memorized that one. So cosine of 30 degrees is not 1/2. It must be the other one. Or another way to do this is to think about our special triangles. So remember your 30, 60, 90 triangle. So that's a 30 degree, a 60 degree. Across from the 30 is a 1, across from the 60 is a √3, and the hypotenuse is 2. So from here, I can remember cosine of 60 degrees equals 1/2, adjacent over hypotenuse. So these must be 60-degree reference angles. Now, the question here has my time in radians, so I can't just start throwing around degrees. This was just to help me figure it out. Now I got to figure out what those would be in radians. Well, 60 degrees, you should remember, is pi over 3 radians. So that's this angle. And then this angle, all the way around, would be 2 pi, all the way around. I didn't go all the way around. I went 2 pi minus a pi over 3. Well, 2 pi would be 6 pi over 3, all the way around. So this angle here is one short of that. That has to be 5 pi over 3. So those times in radians are pi over 3 and 5 pi over 3. And we're not told what t is measured in. So I'll just put time units. Again, you could get the same answers using unit circle. If you want to go through the trouble of drawing out unit circle to answer one single question. Reference triangles are your friend.